So this next section that we're going to be talking about is what we call similarity statements. And instead of doing triangles on a coordinate plane, is we're just going to be doing them in just free space. And I think I need to fix this right here. This should be RST. That should be a T there. So let me fix that. So let's talk about this right here and really what this statement means. So it's saying in the diagram, triangle RST, that little squiggly line right there is talking about similarity. That's what that means. So triangle RST is similar to triangle XYZ. So they're giving us that there's a certain respect here when we have similar triangles, that there's some type of a scale factor involved. And if you look at what we're doing here, this is a new one right here. This is the old. We can use the idea of that scale factor. If I take the new one, divide it by the old, that's going to give us the scale factor K. So this ties in with what we call our similarity statement and how we look at the ratio between these two sides. So the first thing we have to do is we have to write what I call corresponding statements. Corresponding ratios. So if you take a closer look at this diagram here, let me go ahead and erase this. Oops, you can keep yours there. So if I look at side RS, it's the bottom. You can see that both these triangles are oriented on the page in the same way. The smallest sides to the down, the most slanted sides to the right, and to the left is the other side. So RS corresponds to XY. So what I'm going to do is I'm going to write a congruency statement or a similarity statement with the corresponding ratios. I'll have XY. Remember, the new's on top, the old's on the bottom, so new divided by the old, and those numbers would be 18 or 12 over 20. And if I simplify that, 3 times 4 is 12, and then I know that 4 times 5 is 20. You see that the 4's cancel out and I get 3/5. So because these triangles are similar, I can find out this scale factor right here is going to be 3/5 by writing these corresponding ratios and simplifying them down. So let's continue this. Let's look at the other corresponding sides. So if I look at XZ and RT, remember the new is on top, so XZ over RT, that would be 15 over 25. And I know 3 times 5 is 15, and 5 times 5 is 25. That would give me a total of, what, 3/5 again? So do you see that scale factor checks out? And my last corresponding ratio, or similarity statement, so to speak, would be, let's look at ST. That's the old one, so it should be on the bottom, and YZ. So that would give me 18 over 30. And then if I simplify that, that's 3 times 6 and 5 times 6. You see the 6's cancel to 1, and I would get 3/5. So those are some of the things that you'll have to do on this homework, because they'll want you to write the scale factor for each one of these. And you should check all 3 to make sure that it's right, and just don't assume. So it says list all pairs of congruent angles. So remember the idea of the order matters because of the alphabet. So if I'm starting RST, XYZ, so to write the congruent angle statements, I'd have two, let's see, congruent angle statements, that's part B. So I had angle R is congruent to angle X, and angle S is congruent to angle Y, and angle Z is congruent, angle T is congruent to angle Z. Now the reason why they're congruent is, remember, with similar things, they have the same shape but a different size. So the sides may be different sides, but these angles have to be the same in order for them to have the same shape. So this would be angle T would be congruent to angle Z. And the last thing it asks us to do is write the ratios of corresponding sides links in a statement of proportionality. And so that's basically what we did in part A. So the scale factor is 3.5, and so these proportionality statements is what we did in problem number 1. So proportionality statements, look at part 1. So another type of problem that you're going to have is where you're giving a corresponding or similar triangle, and you're going to be looking at the corresponding sides, and you're going to have a missing side. So they're going to give you enough information to where you can write your proportionality statement, and from those statements, one of them is going to have a missing side. So let's take a look at it. So if you look at ED, ED corresponds to this one. Okay, so let's say that this one is our old one. This is our new one. Okay, so ED, line segment ED, ED should be on the bottom because it's the old one. So ED, and I'm looking at NM, and I'm going to set it equal to X over, no, I don't want to use X. I'm going to use DF over MP. So there's my proportionality statement right there. Now I'm going to substitute values in. So the length of NM is 18. The length of ED is 15. And then I have X on the bottom here. And then the new has 30. So remember that idea. It's the new divided by the old. And that's what we have. So this is the new divided by the old. Now it says here we're going to take our cross product. So the cross product is the denominator is going to multiply the numerator. And the denominator is going to multiply the numerator. So that's what it means by a cross product. So the denominator times the numerator, so X is going to times 18 and 15 is going to times 30. So I'll have, let me just finish this down here. So I'm going to have X times 18 would be 18X equals 15 times 30, I think it would be 450. And then I'm going to divide each side. It says to solve for X. So my next step right there would be able to take 18 fix this up. So that's 450. So I want to divide 18 to each side. So I'll take my calculator. I'll take 450 divided by, what was it, 18, and that gives me 25. So that's the answer for the missing side, is 25. So that should finish this part of this video, and you can use it for reference. Make sure you copy this down on your notes and for your reference during a quiz or a test. And thanks.